All right, great. My name is Adam Shepard. I'm the technical director at BCO-DM, which is an NSF-funded data management office. And Doug Fills, who helped on this work a ton, way more than I did, is a data manager at Consortium of Ocean Leadership. So I just want to first off thank Don for giving us a nice walkthrough of FAIR so that I don't have to do that. But this talk is about a group at ESIP, which stands for Earth Science Information Partners, which is essentially just a nonprofit foundation that gathers folks working at NSF, NOAA, and NASA in the informatics to sort of talk about these issues for knowledge sharing. And so there's a cluster there of some folks that are really interested in this aspect of schema.org. And so I just want to sort of walk you through what is schema.org, how it applies to FAIR, and what this group is up to in case it's something that's useful to you all. So when we're talking about schema.org, it's really hitting the F in FAIR. So it's more about findability and not so much any accessibility or interoperability or reusability for that matter. But to get right into it, schema.org is essentially information embedded in HTML pages. And the idea behind doing this is to classify the meaning of certain data elements on an HTML page using terms from the schema.org website, which is just a vocabulary of terms using URIs that Chuck has and Don had mentioned as being important aspects of the FAIR data principles. And essentially, these terms that you're using to mark up your HTML align with this W3C recommendation for data on the web best practices, where if you hone into that sort of interoperability aspect of that recommendation, they talk about how to use URIs to describe a data set, to use URIs to describe the contents within that data set. And so what we're doing is we're taking those principles and really applying them to our HTML pages. And so, for example, with this vocabulary, I can say the whole page describes a data set. I can tell harvesters on the web what the title is, what the funding was for this particular data set, who the authors were, descriptions, keywords, and things like that. And so essentially schema.org, while it's used by web publishers, it's really made so that harvesters, such as like search engines, data aggregators, can come through, use a web architecture to get information about our repositories. And what's really interesting about schema.org is that, I would say 5-10 years ago, there was an activity, obviously a clear need in the sciences for repositories to share information across themselves. And so, there was a lot of talk about, hey, let's implement APIs to share information. You'd see things like, web catalog services, OAI PMH as another technique. And I think there was a little bit of a groundswell, maybe from us lazy programmers, that said, hey, this is ridiculous. I don't want to implement a ton of APIs. It'd be great if I could just sort of publish once and have people come to me. And what was interesting about schema.org is that it sort of gave us this lowest common denominator. Certainly all data repositories have, web pages, hopefully about their data sets. And so this was a way or a mechanism to take all the information that we know about data sets and put them in a place where that would leverage the web architecture for these search engines and data aggregators. So in essence, schema.org is really about a collaborative community that is working on this activity of building a vocabulary that you can use to describe elements of your data sets, but elements of any essentially web page. Primarily this was built by the major search engines, so Yahoo, Google, Bing, and probably more so to drive commerce. So things like hotel reservations, products, storefronts, and things like that. But I think actually it's probably been around for a good while. This concept of a data set in the vocabulary. We were first introduced to it by our all dear friend Peter Fox at Rensselaer Polytechnic Institute. I think probably back in 2014 at ESIP. And a couple of us have just sort of really just latched onto the idea and taken it forward. But the mission here of schema.org is really to create, maintain, and promote those schemas. The schemas are by no means to be considered sort of complete or thorough in that regard. And so they're meant to be extended with other external vocabularies. You can recommend new terms to the community common core of schema.org, but that process is a little laborious sometimes. But the big idea, and this was highlighted in GUA and Brickley's paper there that's cited at the bottom of the slide, was that it was really meant so that it was easy for publishers. And so a lot of the tenets of linked data in the RDF world, semantic web world, are really rigorous, and you have to do it precisely for it to work well. And what's interesting about schema.org is that it's a little bit more lenient in that regard. And so there's multiple ways to publish schema.org on your pages, and there's many strategies about how you might embed that. And so it could be inline HTML, it could be a link to a document in the header tag, or it could even be an HTTP response header that points to this information. And so they've really sort of made it a technique that, however you're rendering your web page, whether it's a single page application, database driven, static, it doesn't really matter. You can use any and all of those techniques to publish schema.org in a way that is easy for your repository. So one nice thing is that the community has put together some nice tools. And so, the barrier of entry is really low. So you can mark up a web page and point that web page at one of these tools here and get feedback right away about how that page is going to be harvested by search engines and data aggregators, which is really nice. You get feedback almost immediately. And the benefits, like I was saying, is that for your repository, you really just have to publish that information once. And it's accessible on a number of levels of granularity. So clearly globally, and at these major search engines, and Google put up a data set specific search engine called Google Dataset Search. And so there's some wins right off the bat by implementing this technique. But also in the sciences, you'll have Data One, which is a metadata aggregator. They are now aggregating using schema.org as a technique for inclusion in their catalog. So that's really interesting. And then more recently, the NSF Geosciences has funded this EarthCube effort called Geocodes, of which Doug is a part of, and has had a big hand in sort of writing software to harvest. So in fact, Doug's software is used at Data One too, and a bunch of other areas for harvesting. And so this is something that, even as you run your own repositories, if you wanted to harvest a portion of the web to grab schema.org, Doug's got some great tools for you. I should have put a link up there, but it's gleaner.io, and we'll make sure that we get that to you if you're interested. All right, so back to schema.org and this cluster at ESIP. The cluster has sort of branded itself as Science on Schema.org, and so that's a URL you can go to find out more information and get sort of like our group's recommendations on how to use Schema.org, because in the data repository landscape, we're well versed in using metadata, and so you'll have repositories that publish out clearly DOI records, ISO records, and a whole other host of metadata like FGDC and EML and all that stuff. And so that's really our bailiwick. And so Science on Schema.org at ESIP really tries to marry the sort of web publishing world that's bringing Schema.org and really overlap that with the work that we've already done in our metadata. And so the group, Schema.org cluster at ESIP, is really trying to help folks understand how to map their metadata into this vocabulary and just sort of do that heavy lift for you. And the idea behind it is that we really have shared publishing patterns as a community, and so that there's reliable and consistent federation. And this is just showing the web page for the geocodes. It's probably changed by now, but that was the page at the time, which would show you what was be able to harvest by the geocodes repository. But then also, because we have these shared publishing patterns and these shared conceptualizations about what a data set is and how it's described, it means that we can write automated validation tooling against this. And so, clearly Google has its own tools, but there was someone in our community that wrote a validator against our specific version of the recommendations that was for describing these scientific data sets. And so you might ask, like, okay, well, schema.org has their own guidelines and documentation. Why do we need like this other set just for science? And for me, it really came down to this fact that when you go to schema.org and browse it, the website there, it's really like these flat descriptions of the vocabulary, and you don't really have a great sense of how conceptually things are linked together. And so if you remember back in Chuck's talk there, when we were looking at that paper and how that graph sort of spread out, we really wanted to address that notion with our guidelines. Also, there was limited examples at the schema.org website, and then just sort of endless ways. And so you could really just sort of get bogged down in trying to figure out how it applies to science. So what we did is we put together, a bunch of code examples, some drawings to help you navigate the guidelines there to make more sense of how you might apply it to the concepts. And then the group just sort of has like this release workflow. We sort of use the Git flow methodology there. We've got a master branch in GitHub. We sort of build up and collect changes to the guidelines, additions and changes, put that into a develop branch, and then just sort of merge out and publish these releases every now and then. We also sort of keep track of the decisions that we make, because clearly reading GitHub issues can be a laborious process, especially with contentious issues. And so we try to take all that discussion and boil it down into these very short architectural decision records, and you can find those at the repository to get a very quick understanding of conceptually and philosophically how we've come to some of the decisions that the group has made. And then I just want to highlight an effort that Doug and I were a part of back in 2018. We got 6 months of funding from EarthCube to sort of build up this initial set of guidelines for science on schema.org. And then with the remaining 2 months, we sort of approached projects that were already funded by EarthCube and said, hey, would you be interested in just sort of trying this out for us and applying this schema.org work to your current websites? And so we had 13, probably 14 projects that were able to implement this in a matter of a couple months, and just wanted to share with you some of the results out of that work there. And so what we saw after 2 months was that we had almost 1.1 million entities across those 13, 14 projects, 7 million triples, which is just to say that we had 7 million statements about all the data sets at these 13 projects. What was interesting is that we found 47,000 data sets. Of those 47,000 data sets, that we had almost 55,000 ways to download those data sets, which was really interesting. So that means some of those data sets had multiple ways to get access to the data, and the repositories were able to describe that. But also, and more importantly to Don's point earlier, was that we found 35,000 identifiers across those data sets. And what's really cool is almost 500,000 descriptions of data set variables, which was great. And that certainly improves findability, and as we talk about fair data principles of a researcher really trying to just hone in on what they're looking for in a data set by variable names. And so, this slide, we don't have to go too much into it, but just wanted to show in that short 2-month span, we had really great coverage over the required properties based out of Google, and then on our own sort of recommendations coming out of science on schema.org. And so that was really encouraging that folks were able to implement this quickly and easily. And then just on some of the recommended, not necessarily required properties of the vocabulary, we saw also some really great usage numbers by the folks that were able to implement this for us. So ultimately, we're still a cluster of an active cluster, I want to say. We're still working on the guidelines. We should have a new release coming out in the next month or two. So this work is still relevant to us. And you're more than welcome to join. We meet bi-monthly on the first Monday, fourth Thursday of the month. Anyone's more than welcome to join. Hit us up on GitHub or reach out to myself or Doug if you have questions. Thank you.